Well, good afternoon, everyone. It's 2 o'clock Eastern Time in the US. I'm not sure what time it is where Dr. Karina Carpentier is. I believe it's at least 7 hours, 6, 7 hours ahead. Also joining us today is Judith Herschell Cole, who is representing the Sensileau platform in North America. We are so happy and proud to be hosting these events, both for the Sensileau platform and also on behalf of the WET Show folks, the water and wastewater education, training and transport. WET operate one of the most successful and biggest trade show training CEU events every year in Indianapolis. We are really hopeful that that will take place next year, but of course, at this point, we're not really sure on that. At the end of this session, we are going to be putting up on the screen a link where you can actually go and contribute to the virtual tip jar for the downtown Indianapolis service industry, the bars, restaurants, all the facilities that help that convention be such a wonderful event, because there haven't been any events held at the Indy Convention Center since early March, and all those folks are hurting really badly. We are really happy to be underwritten this year for the Adobe Connect platform by the WET Show, and there's a message that we've been asked to play from Douglas Lugo before we get going today.
Hello, my name is Douglas Lugo, the director of the WET Show, and I'd like to welcome you to the session. The WET Show team has put together a series of CEU qualification classes that we hope you will find helpful. These are uncertain times. It's extremely important to be up to date on how the wastewater industry has been affected during COVID-19. The WET Show team has launched the WET Plus initiative as a one-stop shop for resources meant to help our industry stand tall. Please visit our site, The WET Show, that's www.ettshow.com, to access these resources. And remember, we are essential. Thank you and enjoy the session.
Okay, so we are a couple of housekeeping things for if you are watching this recording on the Adobe platform. We're going to be putting up the slide deck and introducing Judith and Karina here in a minute. But if at any time you want to make that slide full screen, you will see in the top right corner, and I'll just move this so you can see roughly where it will be appearing. Top right corner, you will see the crosshairs, the full screen toggle switch. If you click on that, the slide will take up as much real estate as you can provide for it. To get back to this general layout, hover your mouse cursor in the same general area, and it will return to this layout. Now I'm just going to do a quick housekeeping here, move that away, move the Sensileau slide deck up to make that as big as we possibly can. And at this point, I would like you to introduce yourself, Judith and Karina, and I'm going to mute my microphone. Take it away.
Okay, Karina, would you like to start?
Yes, fine. Hello, everybody. My name is Karina Carpentier, and I am the co-founder of the Sensileau sensor platform. We started the platform in 2017. I have a background in aquatic ecotoxicology and have been active in online and on-site field monitoring of water quality in the water industry for the past 25 years.
Okay, thank you, Karina, and thank you, Dendra, as well, for hosting the webinar today. My name is Judith Herschell Cole, and I am a biologist and mechanical engineer with 36 years in water and wastewater treatment and engineering, from both the supplier side and the engineering side. So I'd like to welcome you to the webinar and thank you for joining us. As questions arise, please type them in the sidebar and we can address them at the conclusion of the webinar. We are pleased to present the following presentation on tools to optimize operations at water and wastewater facilities and how these can enhance operations and address challenges presented in this global pandemic of COVID-19. To meet today's challenges of water scarcity, climate change, stringent regulations, water quality issues, aging infrastructure, funding shortfalls, and more, water utilities increasingly rely on data to address every aspect of their business. Utility professionals must be able to use their data to solve challenges, improve sustainability, boost resilience, reduce costs, and improve their systems overall. There are many challenges that sensors can address. These include minimizing water loss by continuously monitoring water usage and reporting anomalies, protecting water resources by detecting specific parameters of concern and changes in source water, boosting treatment efficiencies by monitoring system pressures, electricity usage, chemical addition, and other operational parameters, recycling water by treating to a specific water quality, valuing water by closely defining the costs of operation, treatment, and distribution, combating climate change by minimizing power usage, and attracting talent by appealing to a younger and more technically savvy personnel. Sensors provide actionable information to find and resolve problems more quickly. Real-time data is available to operators. They provide a full picture for better business decisions and planning, conducting operations without these details to lead to extra work and additional costs. Looking at the whole picture provides a better understanding of the general and detailed health of the utility. Accurate sensor data leads to proactive versus reactive decision making. The problems are more apparent when data is clearly available. And then this data leads to a better understanding of the entire water system at all levels, providing a full picture for all team members so that a better overall process is realized. This promotes teamwork and knowledge sharing among the members. From the customer standpoint, their water quality and reliability are improved, resulting in happier customers. All of this culminates in operators' ability to make informed and smarter decisions regarding their operations, maintenance, and planning. In addition, sensor systems are scalable and allow a utility to address their top priorities first for quick successes and then expand the system to manage the entire water cycle as needed. This scalable solution is flexible as the utility's needs change. Our approach to sensor implementation follows a four-step plan. First, take inventory of sensor systems that are currently in use and take offline all sensor systems whose data is not being used and optimize the use of those that remain. Develop standardized maintenance protocols for sensors and for the treatment system and distribution system. Implement routine quality assurance with a focus on remote monitoring equipment. Quality assurance involves resetting instruments, cleaning them, and recalibrating. And then start small. Begin with one sensor type and then extrapolate to other sensors. I would like to highlight four central benefits of a well-planned sensor system. First, well-structured management and operations bring efficiencies through the system optimization and projecting potential failures and planning maintenance to eliminate these failures. Online sensors operating at peak performance provide eyes and ears on the system and note any changes that may occur. Inclusion of online monitoring assists in conforming to the requirements of ISO 17025 accreditation, bringing legal acceptance and approved efficiency. A reduction in costs, while always important, is critical as we navigate to a post-COVID-19 economy. Our next slide begins a case study wherein a 30% cost reduction was realized. This case study highlights cost savings of 30% per year, savings of $215,000 Their costs were beginning at $650,000 a year and have been reduced to $435,000 per year. This is realized at the City of Rotterdam in the Netherlands water treatment facility. Through an increased reliance on sensors, they were able to reduce water quality monitoring and reduce water sampling by 40 to 60%. With the onset of COVID-19, they were able, due to the sensors that they had previously installed, to reduce sampling in the distribution network and institute limited sampling at public buildings. They completely eliminated sampling at private homes. In addition, they had linked the output of the sensors to the central control system. This allowed most of their staff to work remotely. They were able to go to a skeleton crew, reducing the on-site workforce from 10 to 15 people, now down to only 2 or so. This has significantly increased safety for all employees. They also rely as much as possible on online water quality and quantity sensors. Sensors feed the information to the control room computers. The operators can connect to the control room computers, and they can do anything that they can do directly when in the control room. They can monitor system operation, including the treatment equipment and distribution network, start and stop pumps, view tank levels, and so on. The City of Rotterdam is realizing the following results: energy savings and reduced labor costs, resulting in the 30% savings that I mentioned, information sharing between employees from their separate locations, and increased safety due to fewer employees being on site. Next, I would like to present COVID-19 testing in wastewater treatment systems and case studies in wastewater treatment. There is a concern of COVID-19 exposure at wastewater treatment facilities. Findings suggest that the virus can be transmitted through human waste. The detection of COVID-19 has some positive aspects, as it may be used to detect the virus prior to it being found in the local population, and also to predict the severity of an outbreak. It is thought that health authorities are only seeing the tip of the iceberg as far as the magnitude of the virus on populations. Monitoring influent at wastewater treatment plants could provide better estimates for how widespread the coronavirus is as compared to testing of individuals. Wastewater surveillance can account for those who have not been tested and have only mild or no symptoms at all. But to quantify the scale of infection in a population from wastewater samples, researchers say that the groups will need to find out how much viral RNA is excreted and extrapolate that to the number of infected people in a population from concentrations found in the wastewater samples of viral RNA. As noted, findings suggest that the virus can be transmitted through human waste. So detecting the virus in sewage sludge is not considered a threat to employees. However, finding coronavirus in sewage could be a risk. The concern of COVID-19 exposure at wastewater treatment facilities is primarily around aeration basins. The aeration basins can release airborne pathogens, similar to the issues that have been experienced in the past with Legionella bacteria. When Legionella bacteria multiplies in water and is then aerated, such as in HVAC systems, spas, and decorative water features, it is introduced into the air. When the airborne bacteria is breathed, the infection takes hold. A similar scenario is possible for airborne COVID-19, underscoring how important it is that we protect those wastewater treatment professionals from pathogens that they may face during their workday. Professors at the University of California, Riverside and the University of Salerno published an editorial perspective in Environmental Science and Water Research Technology. Last month, this was published, and they stated that the new coronavirus can be transported in aerosols. They also said that left untreated, the virus can remain infectious for days or longer in wastewater. But the upstream treatment plant's disinfection processes, the potential combination of threats through aerosols and feces may be ongoing work hazard in many of our nation's wastewater treatment systems, where aerators are swirling or splashing on the surface of aeration tanks, or basins kick up clouds of tiny pathogen-laden droplets. In short, these surfaces can produce aerated virus that can be a highly efficient mechanism for lifting the pathogens into the air in little infection-ready packages and exposing workers to them. Whether the pathogen is COVID-19, E. coli, Cryptosporidium, or another such bacteria or germ, aerosolizing it represents a serious risk. Maintaining surface aerators can be dangerous. Workers breathing in these aerosols, breaking down and rebuilding splashers or jets, fixing motors, balancing off catwalks to access aeration equipment. It's all a recipe for disaster as our country navigates its way back to normalcy after the pandemic of COVID-19. Our hope is that the recovery plan will focus a major effort on ensuring the safety of those working around municipal and industrial treatment facilities, as well as other areas that are considered to be likely risk factors, such as livestock manure lagoons, as there have been recent information on animals being susceptible to the virus as well. Viral RNA has been found in the city of Amersfoort, the Netherlands, before any infections had been reported in the community. The genetic material from the coronavirus was detected at the wastewater treatment plant on March 5th before any cases had been reported in the city. Studies have also shown that the virus can appear at wastewater facilities within 3 days of infection. This is much sooner than the time for people to develop symptoms severe enough to seek hospital care and to get a diagnosis. This can take up to 2 weeks. Tracking viral particles in wastewater could give public health officials a head start on deciding whether to introduce measures such as lockdowns. In these types of viruses, 7 to 10 days can make a lot of difference in the severity of an outbreak. In 2003, the World Health Organization published a report on the spread of SARS, a close cousin of this coronavirus and a model for our current acute respiratory virus outbreak. They saw this through the faulty wastewater handling system in a Hong Kong high-rise. A recent study in the Annals of Internal Medicine found that samples in patients' phlegm and feces tested positive for traces of COVID-19, even after swabs from their noses and throats came back as negative. We don't know yet how long the virus will survive in wastewater. More research is needed to develop a test and the requirements to employ it. One such company that is approaching this market is an MIT startup called BioBot. They have been screening wastewater for coronavirus. They're testing sewage in 150 facilities across 30 states in the U.S. One such facility is Newcastle County in Delaware. They just completed the first week of testing with BioBot. In its first pilot, which was a 24-hour test, BioBot estimated there were 15,200 cases of COVID-19 in Newcastle County, Delaware alone. Those results far outpace the 4,034 estimated number of confirmed cases in the entire state of Delaware. Another example of benefits of sensor technology is the implementation of phosphate monitoring. This graph shows data after treatment and before phosphate recovery. This is for the purpose of recovering this compound that is expected to be scarce in the future. It is difficult to recover when levels are unstable. The effluent levels were optimized in the last third of the graph shown here, by use of a phosphate analyzer. They were able to realize a savings on investment of over $100,000 per year and a simple payout in 1.2 years. In this portion of the webinar, I'll review the sensor platform that is offered by Sensileau. There are a dizzying number of sensors entering the market each year. Here's a small sample of available sensors with the types of sensors, capital costs, operating costs, technical details, advantages and disadvantages of each, and so on being of importance when deciding on sensor use. The sensor platform brings clarity. For most people, this can be a confusing and overwhelming task to fully understand. For each sensor, specific questions must be answered to gain maximum benefit for the utility and to give a concerted approach to the changes for each utility. What should be monitored and with what sensor? When should a specific technology be employed? Why should the technology be employed and monitored? How should the sensor program be implemented? Gathering this information would require a significant amount of time, and complete information may not be assembled by the researcher. Our goal is to provide meaningful information to our clients, to provide insights and assist in decision making, support the goals of our clients. The basis of the platform is the sensor database. This will be detailed in the slides which follow. In addition, information on sensor installations is included in the platform. This is meant to boost treatment efficiency and effectiveness and help the utility to meet treatment and economic goals. We provide the option for specific design input for our clients as well. Other information is presented in podcasts, webinars, workshops, and upcoming e-learning opportunities. In the Sensileau platform, there are 75 different parameters shown and over 10,000 water quality sensors from approximately 300 manufacturers. We show the entire water spectrum from source water intake to drinking water treatment, drinking water distribution network, sewer systems influent wastewater treatment, wastewater effluent discharge, and a complete overview with 250 reports and articles from international literature and over 200 interviews and surveys with water utilities worldwide. This is the main screen in the platform. It shows 7 options and brief instructions on how to use the tool. There is a searchable database starting with welcoming you and showing you how to use the sensor platform. Topics to be searched can be put in the search bar on the left side of the screen. Across the top on the right, there are 6 categories shown. First, information, which tells details about the parameter to be monitored and the principles of measurement, and the principle of operation for different technologies and the advantages and disadvantages of each. Benefits of various approaches in monitoring specific parameters, and an overview of acquisition or CapEx and maintenance or OpEx costs. Practical experience, customer satisfaction rates. Also outlined are best practices, how to implement sensors in your process, including installation, maintenance, and calibration, and an interactive list of suppliers with company websites included. So as an example, if we select source water intake option 1 from the myriad options on the platform, a long list of options for various parameters may be viewed and selected. As you can see in the box to the bottom right, the blue highlighted box is permanganate, and this has been selected as our parameter of interest. Clicking on this takes you to the screen on the right and brings you the information page for permanganate. This section describes the parameter and where it is found. Apologies for that glitch, and we will be following up so that you can You'll have our contact information and be able to address any questions you may have. And as we move along the banner at the top of the boxes shown here, we click on Principle and then on Benefits. Principles behind both the colorimetric and spectrophotometric methods for permanganate are included. The benefits, in addition to the advantages and disadvantages of each of these approaches, are shown. The information presented is clear and concise, providing details of central importance. Next on the banner is costs, including acquisition and O&M costs of the colorimetric method and the spectrophotometric method. These include CapEx and OpEx, with the OpEx including chemicals, spare parts, labor, and expected lifespan of the instruments. The results of a customer survey regarding their satisfaction with the approach includes the design, ease of installation, reliability, accuracy, required maintenance, and overall satisfaction with the instrument. For the category of best practices for both approaches regarding operation and maintenance, calibration, and application of the technology is included, with quite a lot of information and detail provided. The final and rightmost category in the list is a list of companies that supply the sensors for this specific parameter. In this case, the suppliers listed are for colorimetric and spectrophotometric methods. Sensileau offers a range of practical tools to maximize the benefits of sensors when facing major water challenges. Our system uses credit so that you can select and pay for only the tools that you use, and when you share your experience with other platform users, we reward you with credits as well. You can read the frequently asked questions section of the website for more information. We offer each attendee a free account, and then you can use whichever features you desire to use, no strings attached. But if you would like to benefit from considerable savings on what we have to offer, you can pre-order your credits for yourself and your team at an attractive discount, and packages are billed annually. You can follow these steps in order to use the services from the platform. First, you create your free personal account, allowing you to use all of the free services that we offer on the platform immediately. If you wish to use some of the paid services on the platform, a purchase of credits is needed, and follow the steps to gain access by choosing the package that you'd like, or you can use the help button to help you decide which package best suits your needs. Select the number of credits that you'd wish to purchase and enter any further details that are requested, and then send the application to Sensileau. As soon as we have received the application, we'll send a confirmation message detailing your purchase. After a PO or payment has been received, we add credits to the account, and as of that moment, you and your colleagues can use all of the services that are offered through the Sensileau sensor platform. We are a team of 5 keeping abreast of the ever-developing field of sensor technologies, communicating with water and wastewater treatment system operators, supporting the platform, preparing webinars, white papers, and podcasts, and adding value to our subscribers. We appreciate your attendance and welcome any questions you have. I want to thank you, Dendra and Wastewater Education, for hosting this webinar. And we again apologize for the glitch, but if you have some questions now or later, we'd be happy to address them.